Okay, thank you everyone for listening. If you want to break into networking, cybersecurity, DevOps, or cloud engineering, you must understand how VLAN talk to each other. VLAN means Virtual Local Area Network, and this is used to segment our network. It is used to make a physical switch to be isolated into different networks, and each VLAN is a broadcast domain, which means any device on that VLAN will receive any traffic you forward. They can talk to each other just like your home network. All your devices are in the same VLAN broadcast domain. So now I'm going to be teaching you with a topology in networking we call router on a switch. A router connecting to a switch, and then that switch is a layer 2 switch, and then that particular switch is in the access layer of the network. And then we have the end devices, switches, cameras, and everything. So that's what I'm going to be illustrating. This is going to teach us how to do broadcast domain isolation, how to do layer 3 routing between VLANs, and then how to implement MQ, trunk, and access ports. A trunk port carries multiple VLAN that is configured between switches to switches, route, switch, and router, and switch to firewall. We use trunk port. They carry multiple VLAN through a protocol we call 802.1q, which we configure on the layer 3 router. And then we also have the access VLAN, which is the access port. The access port carries one VLAN, that is the switch on the switch port that is connected to the end user devices. So now quickly, we're going to be designing a topology to teach you and verify that communication between two VLANs require a router. A communication within the same VLAN does not require a router. It is a broadcast domain, and all traffic can go straight away once configured. So we are configuring from scratch. We drag out one router, 331 series router, and then we drag out a switch quickly, and then we drag out a PC. We need 3 PCs actually, because I want to put 2 of them in the same VLAN and then the other one in VLAN. So let's assume we have so this is designing a network. This is how network architects do. This is what they do in real time. So you are learning exactly what network architects do. So I get a straight through cable. I click on this cable. If you want to do this, you need to download Packet Tracer. It's free of charge. And then you can register on their website and install it on your PC. Just Google Cisco Packet Tracer and then register and then download it. They also have some pre-made labs. You can just open that lab and you will see the one that says router on a stick, and then you use it to practice this, or you can do what I'm doing. Follow me quickly. You will learn something that we do. So on this router, I click straight through cable, and then once I click on that, I select the facet 0/1 of the switch, and then I get the cable again. I connect the switch to each of these pieces. Facet 0/2 goes to facet 0. I get the cable again. Facet 0/3 will go to PC, and then facet 0/4 will go to the PC facet 0. And then once I do that, I can label it to make it very clear what I'm doing, so it will be easy for you to understand too. I can draw a rectangle to just segregate the network into those layers. And then I will say this is access layer. We used to have distribution layer before this access layer. And then we can say that these two are in the same broadcast domain VLAN. And then this one, you can have other ones, so I just choose only 2. And then we can now get and then we design our network and say what the IPs will be. So we have HR. HR has VLAN 100, and then the IP range is 192.168.100.1. And then we have sales with the VLAN 200. The first network is HR network, and the VLAN is 100. And then the IP address range is 192.168.100.0/24. Second one is sales, and the VLAN is 200, VLAN 200. And then the IP range is 192.168.200.0/24. That is our network. And then I label each of these interfaces. So this one is 0/4. And then so that when we are working, we will be able to remember them. We don't have to struggle. Here's 0/2. And then this one is F0/1. And then this is the access layer if we are layering the network. So it doesn't just a concept. Or yeah, there can be distribution layer, another switch here, which I will do in another lab. So here we have this PC, VLAN 100, which is meant for HR people. And then we have this one, which is sales. So it will get an IP within that range. Sales is VLAN 200. And then we give this one the IP address 192.168.200.10.24. We give this one 192.168.100.10. And then we give this one 192.168.100.20 plus 24. So we'll put the subnet max. Now, once we do that, then we can add the MAC address there, the MAC address. So now, once we do that, we start configuring. I put this MAC address because I want to know the MAC addresses of these PCs so that when we are doing our testing, we'll be able to identify them. So that is it. So this is our network, and then we can start configuring from the host. For host configuration, you know that every PC will have the IP, the default gateway and IP address is subnet mask. So if you do IP config/all on your computer, you will see I have many interfaces, virtual machines that I am running. But if you look here, you will see that you have a gateway, you have an IP address, you have an IPv4 address, and then you have a subnet mask. So this subnet mask and gateway is usually .1, but you can change it to something else. But by default, the PC takes one of the last octet of that IP address. IP address usually have 4 octets, and each of these octets are 8 bits. So we start from the PC. I start from the PC. I open the PC. I go to CLI. I'm going to configure it with IP address, gateway. And then, I forgot to explain the gateway. So this interface, because the switch will have 2 VLANs, so it will have VLAN. We are going to be configuring VLAN 100 and VLAN 200 on the switch. So those 2 interfaces, this switch will have this VLAN 100 and 200, and they will have to pass through here because communication between VLAN 100 and 200, if PC0 or PC1 wants to talk to or ping or send information to PC2, a router must be needed because it is between 2 VLANs, 2 different broadcast domains. So if traffic is sent to the switch will need the router, and then the router has only one interface connecting to the switch. So assuming we have 100 VLANs, so how does this single interface identify and be able to separate and isolate the broadcast domain traffics and know that this is for VLAN 100, 200, 300, 400, 500, whatever number? VLAN ranges between 1 and 4094. So now we configure the router. We want to break the router interface into sub-interfaces and then define 1Q, which is the protocol that will allow that to happen. So the first interface, this router interface is G0/0/0. But we're going to break the router interface G0/0/0 into 2 sub-interfaces carrying VLAN 100. So G0/0/0.100. And then we give it a gateway IP address with a subnet mask. And then we do the same, the second one for VLAN 200.200. And then we give it an IP 192.168.200.1. We are giving it .1 as a gateway. So that router is going to become like our modem at home, which allows us to get to the internet. So it is going to also be responsible for allowing traffic to flow between 2 different networks, 2 different VLANs. Netting is where you learn how to subnet, break your network into different broadcast domains and different networks. So now we configure this switch. So we want the switch to have 2 VLANs. So we do config T. So first of all, when you come in, the switch will give you this mode. So when you enter, you type enable to enter this privilege mode, and then you do config T to enter the configuration mode. You can show run to see all the configuration on the switch. If you look, there is no configuration on the interface, and then there is no VLAN now configured. So now I'm going to start with configuring VLAN. So I say config T, I say VLAN 100. And let the name be HR. I can give it HR. And then VLAN 200. Let the name be sales. And then I say, you show VLAN. It will show me the 2 VLAN, but those 2 VLAN needs to be assigned port. Which port will carry that VLAN? So this port on the switch, because we're configuring the switch, is faceted on 0/2 and faceted on 0/3 will be in VLAN 100. So 0/2 and faceted on 0/3 will be in VLAN 100, while fast Ethernet 0/4 will be in VLAN 200 as we stated here. So now I will do that and say interface fast Ethernet 0/2 or I can use interface range. That's how we do interface range. Facet is 0/2, 0/3. And then I say switch. I can do it separately for each of them. Switch. Let me not do it together. So let me say interface facet is 0/2. So to make it easy for you, switch port mode access, because that's interface connecting to an end user device on the switch. The interface connecting to an end user device on the switch is an access port. So we need to make it switch mode access because it's going to carry only that VLAN, which is in this case is VLAN 100. And then we tell it the VLAN to carry 100. No short. We bring it up. Then interface facet is also 3, which is the one on PC1. So this one on PC1 is facet is also 3. And then I say switch port mode is access. Switch port access VLAN 100. No sure that I want to bring it up if it's down. You can make this your culture so you don't miss an interface, which will cause you a problem when you are troubleshooting. Why is this not working? If you don't remember to do no sure, then you might waste your time. So now we configure the last interface, but it's VLAN 200. So we go and say interface facilitator/4 switch port mode access. Switch port access VLAN. So you can see those two interfaces. The three of them are up, but the facilitator 0/1 is down because the router has not been configured. That's the one connecting to the router. But let's see if the VLAN we configured are there. Do show VLAN. You don't have to do show VLAN. You can end and come back to this mode and just show VLAN. Once you do that, it will show you those VLAN 100 has access port FA0/2, which connects to PC0, and then FA0/3, which connects to PC1, and the same thing applies to PC2. PC2 connects facilitator 0/4. Then once you do that, then you write your config, right, so that it will save everything so you can see that you're done the switch config. If you want to see the interfaces, you also show run and see what you have configured on each of them. So now for the interface that is connected, config C again, the facilitator 1, which is connected to the router, it will say switch port mode trunk because it's going to carry two VLANs to the router. So even if you do show IP interface, it's still going to be down because the router has not been configured, so it's still down. So don't worry, when you bring up the other end, it will also come up. So now we go to the router. We have configured this everything here. We go to the router. I'm going to go to the CLR. No, don't want to go to that mode of configuration. So we do enable. When you do EN or enable and then config, you can check what is configured. Sure run. So there's a good culture to see what they have configured. There is no configuration on that interface connecting to the switch. And then there are other interfaces. So, and then I'm interested in the console. So now we go to that interface G0. So 0, we break it into 2. 1 is 100. And then we give it encapsulation because we want it to carry to VLAN 200. Encapsulation.1Q is say 100. VLAN 100, not 200. And no short, you have to bring up the physical interface first. Then you go to interface G0 0.200 and we haven't given it IP address. So IP address 192.168 with 255.255.255.0. I don't worry about, I'm not sure. So interface, we go to the next one. Interface G200. So encapsulation, we are telling it to carry the VLAN to become the gateway with this .1Q protocol to be tagged for VLAN, any VLAN that is tagged. Encapsulation 200. So then you need to give it the IP address of that gateway because that interface is a gateway with which the traffic would go. So now you go to the physical interface and bring it up. So those ones will come up too. So now they are all up. So you cannot do show IP interface brief to see. But you can see they are all up. So at this point now you need to write your config, the same thing you did. So you can type write or WR and write it. So now if you show IP, if you show run, you can see everything that you have configured now. You can see both of them. So now you have enabled this router, this traffic to go from here to here. So that is it. What do? We want to test and see if traffic goes from here to here through trace route. We need to go through the router. We're going to see router on the path. the gateway of the router. Okay, let's go to this PC and do trace route to this PC0, trace route to PC1 in the same VLAN. 100.10 trace route to 100.20 IP, the last 2 octet. So we come here, we click, and then we click on desktop, we click on terminal, sorry, not terminal, we click on command prompt, and then we say trace at 192.168, but 100.20, which is the IP address of PC1, and then we'll see that the traffic will go straight. Okay, so once you have such issue, then check if you have done something wrong. So we are trying to trace route to this. So let's see if we actually configure the gateway very well first. We missed the gateway for this one, so that's one troubleshooting, which is good. So you learn about this. You go here and configure that one, and then the gateway 192.168.100.1. So that's done. Okay, we need to get the MAC address too, so that when we do our checks, we'll be able to recognize it to the device. So we check it. So let's check this one and make sure that we did the configuration. We didn't configure these ones. We did the first one on the dot 200. I think we configured only this one. It didn't do. Okay, we haven't configured the PC, so we need to configure the PCs at the beginning, but it's okay. We add an IP address to the PC for 10, and then 255, then we go to the gateway 192.168 for 100.1. That is the gateway, which is this interface VLAN. So now we can now go and do our ping. So now we go here, and then we do our trace route from PC0 to PC1, and then we'll see if it will go through the router .1.100.1. We'll see that it will go straight down here. It's not going to show any IP address .1 up there. That's see how it went straight from this PC I am on is 100.1, which is PC0 wants to talk to PC1. It went straight from the switch. It didn't require the router to do that. So that is it. And then we can also ping it, so which shows that there is switchability. So ping shows us that we can talk between the two devices. If you send an echo request and then there is a reply, so it shows that we sent 4 packets and we received 4. There was no loss. That shows that communication does not need this router. So we can disconnect this router and still be able to talk between the devices. But when PC0 wants to talk to PC2 on a different VLAN, see what happens. So we trace route, because trace route helps us to know the path that the traffic would take. You will see that it will show the IP address of this gateway of the router, meaning that the switch had to forward it to the router, because switch cannot. It's a layer 2 switch. So if it's a layer 3, it can do that routing. Routing occurs at the layer 3 of the OSI. It needs IP address for routing. So now when I do that, it will show the IP address of the router 100.1, and then before it switches to the main host you are trying to ping. So you're pinging 200.10. Went from, look at this, to different between this and this. So the first one went straight to the device you are trying to locate how to talk to. So the traffic goes straight. It shows us the path that is traces the route to a destination. So it traces the route from PC0 to PC1. Now this one traces the route from PC0 to PC0 to PC2. So it tells us that this traffic went from here, it went to the router before it came down. So there is also some layer 3 switches, so be aware of that. So that is it. So that's what we have learned from this. You can also go to the switch. You can see that the switch have learned a lot of, because switch learns the MAC address. Show MAC address table will show you what the switch have learned. So when you forward the traffic first, if the switch does not know where to send it, to learn the MAC, and then in the next upcoming conversation, it will know where to forward traffic. So VLAN, this is interface facetness 0/1 of the router. It knows that gateway VLAN interface G0/0/0/100 uses an interface facetness 0. So once you forward this through this facetness 0/1, it goes to a router. Then it also knows that facetness 0/2, which is, this is the MAC address of PC0. So I didn't take the MAC address, but if you click on that, you see that it is the MAC address. This is the MAC address. We do the same for this one. You can get the MAC address, and so that when we ping it, we will know that, so we can see the MAC address. So now on the switch, we can see that. So the MAC address ending in 77A is from facet ethernet 0/2. So the switch understands that if it wants to forward the traffic, it will just drop it on this facet ethernet 0/2 and it must get to PC 0. Same thing applies to facet ethernet 0/3. It drops it on this and it shows you that it is in VLAN 100. So this one is also VLAN 100, and the MAC address of that device for layer 2 communication is ending in 0201. So it's ending in 0201. So once the switch wants to communicate, it drops it on this interface facet ethernet 0/3, and then it will go to that device with that MAC address. The same thing happens to 200. From this, it goes to the gateway, which is a gateway IP we configured up there, and then it drops it down to this VLAN 200, and the MAC address of the device ends in 015C. Notice for this one. And then the facet, it drops it on facet 0/4. Okay, I forgot to show you that we can also ping from PC1. So PC, let's do the ping quickly, and then we end this. So we can also ping to show connectivity 192.168.200.10 pinging. So you can see that there is ping from PC0 to PC2, which is in VLAN 200. So that is the last one I wanted to show you. So thank you very much for listening. Have a good day. Bye.